Okay, this is the homework video for exercise 8.6 and some more examples for exercise 8.7. So just doing two more examples from exercise 8.6. The first one is question 10. The tangent at point P on the curve y equals 4x squared plus 1 is parallel to the x-axis. Find the coordinates of point P. Now we're talking about the tangent to this curve, so we need to differentiate the curve first. So if y equals 4x plus 1, 4x squared plus 1, then dy dx is 8x. Now, we're told that the tangent at point P on that curve is parallel to the x-axis. Now, you don't have to sketch this, but I am going to do a quick sketch. This is the curve y equals 4x squared, which is a steep parabola shifted up 1 unit. So the parabola will actually just look like this, okay? Now we want the tangent at point P on this curve is parallel to the x-axis. Now this is the x-axis. For the tangent at our curve to be parallel to the x-axis, we know that the x-axis has gradient equal to 0. Therefore, the tangent at point P has gradient equal to 0 as well. Okay? So the gradient, that's the tangent at point P. If it's parallel to the x-axis, then that tangent at point P will have to be down here. So the tangent at point P will have gradient 0 as well. And we need the coordinates of P. I can actually already see them. The coordinates of P are 0, 1. But I'm going to do it by substituting dy dx equals 0 into the equation dy dx equals 8x. So we know that dy dx is 8x, but we want to know for what value of x is this gradient going to be 0. So we end up with 8x equal to 0 because we're putting dy dx equals 0 in there. And so x is 0. And we know that when x equals 0, we're trying to find the point on the curve, that y equals 4 times 0 squared plus 1, substituting it into here, which is 1. Therefore, point P has coordinates 0, 1. Okay? Actually, that question could have been done just by observation, but we're differentiating here, and you can see that it also works with differentiation. Now, one more question, exercise 8.6, question 12. Find the coordinates of point S where the tangent to this curve is perpendicular to this line. Okay? So you can either start by working with this line and finding its gradient and the gradient of a line perpendicular to that, or you can differentiate this. I think I'll start with the line, okay? So we've got this line 4x plus 2y plus 7 equals 0. Now you want the coordinates of point S where the tangent to your curve is perpendicular to this line. So in other words, the tangent to that curve, if you work out the gradient of the line perpendicular to this line, you'll know what the gradient of the tangent to your curve is supposed to be. So let's look at this. We've got the straight line 4x plus 2y plus 7 equals 0. We're going to put that into y equals mx plus b format so that you can work out what the gradient of this line is. So we've got that 2y is minus 4x minus 7, dividing through everything by 2. We get y is negative 4x over 2 minus 7 over 2, which is y equals negative 2x minus 7 over 2. So the gradient of this line, the gradient of your line, is negative 2. But the gradient of the line perpendicular, of the perpendicular line, perpendicular to this, now that's negative 2 over 1. The gradient of the line that we want is a half. So therefore, the gradient of the tangent is going to be a half. Okay? So we know that the tangent to the curve, if it's perpendicular to this line, then the tangent to the curve will have gradient a half. So let's start with our equation, and if we want to know something about the about the tangent to this curve, we need to differentiate it. So dy dx is 2x plus 4. Now we know that the gradient of the tangent is equal to a half. So we're going to substitute dy dx is a half in here. And we get that a half equals 2x plus 4. And we can take this half, actually we can bring this 4 over, so we get that 2x, bringing this, we get a half minus 4 is negative 3.5, which is negative 7 on 2, and therefore x is negative 7 over 4 if you're dividing here by 2. Okay, now that does not give me the coordinates of the point S, that just gives me the x value. So to find the coordinates of S, I need to substitute this x value that I've got into my original curve. So we know that x is negative 7 on 4. We're trying to find the coordinates of point S, and S lies on the curve. So we're going to substitute x equals negative 7 on 4 into our original equation, which is y equals x squared plus 4x minus 1. And we will get y equals negative 7 on 4 squared, now that will be positive, plus 4 times negative 7 over 4 minus 1. I'll just bring this back down here. So squaring a negative, you get a positive, so you get 49 over 16. The 4's here cancel, and you'll get minus 7 minus 1. And you might want to get your calculator out. I think 16 times 3 is 48, so that's 3 and 1/16 minus 8. I think it's negative, it's I just better work that out one second. It's negative 4 and 15/16. Therefore the point S on the curve is negative 7 on 4, negative 4 and 15/16. Write it actually as negative 1 and 3/4, so negative 1 and 3/4, negative 4 and 15/16. Okay, that's the examples for exercise 8.6. I'm just going to do some examples from exercise 8.7 now. Exercise 8.7, some further examples here. The first question is to find dy dx if y equals x plus root x squared. Before you do this question, you would simplify the way that this looks, so you would expand it. So remembering when you're expanding that, this is of the format a plus b all squared, so you get a squared plus 2 times a times b plus b squared. So simplifying that, you would get x squared plus, now 2x times root x is 2x times x to the half, and the square root of x squared is x. The reason we're writing it like this is that you cannot differentiate it in the format of x root x. You need to make it as x to the power of one thing only. So we get x squared plus now 2. X times x to the half is x to the 1 times x to the half. Now the bases are the same, you add the indices and you get 1.5 or 3 on 2. So we get x squared plus 2x to the 3 on 2 plus x. That's what y is, so therefore dy dx will be, now we can differentiate it, and we get 2x plus, now keep the 2 in the front, bring the power to the front, so you get 3 on 2x, and then we do 3 on 2 minus 1, so that's 1.5 minus 1 is a half, plus if you differentiate x, that's like differentiating 1x, you get 1. So differentiating that, we get 2x plus, now notice these 2's here cancel, so we get 2x plus 3 times x to the half plus 1. Now we can rewrite 3 times x to the power of a half as 3 root x, because if you look at the question, there are no fractional indices here. So, you know, this x, root x, is not written as x to the half, so this x to the half needs to be written as root x here. So we get 2x plus 3 root x plus 1. Okay? Okay, question 11a, differentiate root x on x. We'll need to take a similar approach to what we just did. So we've got that y is root x on x, which is x to the power of a half over x to the 1. Now we don't want this as two functions in x, so remember bases are the same, we subtract the indices, so a half minus 1 is negative a half. So now we can differentiate that, so therefore dy dx is, see this is in the format of x to the power of n, so we can just bring the power to the front and we get negative a half x, and we have to do negative a half minus 1, which is minus 1.5, which is negative 3 on 2. Now, because this is part A of the question and we're doing part B down here, I'm going to leave it in this format rather than writing it with roots and all that, because to find the, oh actually no, I will change it. I will change it. So it's negative a half. The reason I'm changing it is that we're going to be substituting values in, and it'll be best to change the way it looks. Now this is negative half x to the minus 3 on 2, which is x to the negative 3 on 2 is 1 over x to the 3 on 2. Now I'm going to write that with roots. Now that's the square root of x cubed. So therefore that's the derivative there. And that's when we differentiate that, we end up with this. Hence find the gradient of the tangent to this curve when x equals 4. So we're just substituting when x is 4, we're just working out what dy dx is. So we're substituting it into this. So we're subbing x equals 4 into this. And we get negative 1 over 2 root x is 4. And then we're cubing it. Now I wouldn't do the 4 cubed first. Okay, remember this is a big 2 here. This is 2 times the square root of x cubed. So it's negative 1 over 2 times, square root of 4 is 2 cubed. Oops, running out of room there. So it's negative 1 over 2 times 8 is 16. So therefore the gradient of the tangent to this curve at the point where x equals 4 is this. Okay, so therefore the gradient of the tangent is negative 1 on 16. Okay, when x equals 4. Okay, question 12. Find the equation of the tangent to the curve y equals 4 on x at the point 8.5. Now, we start off with our equation, with our curve. Now, we cannot differentiate that because it needs to be in the format of x to the power of something. So this is 4 times x to the power of negative 1, or just 4x to the negative 1. So now I can differentiate it. So dy dx is, now I leave my 4 there, I bring my negative 1 down and I get negative 1x, and then I do negative 1 minus 1 is negative 2. So this is 4 times negative 1 is negative 4 over, now x to the negative 2, so this is really negative 4x to the minus 2, but I'm going to write, I don't want to see this negative power here, so x to the negative 2 is 1 over x squared. So that's what my derivative is. So this is my gradient function. It gives me the tangent to the curve at any point I want. But I want the tangent to the curve when x is 8, or at the point 8.5. So when x is 8, I'm trying to work out what the gradient of the tangent is. And so I substitute x is 8 into there, and I get negative 4 over 8 squared, which is negative 4 over 64, which is negative 1 over, I think, 16. So that's the gradient of the tangent to the curve at that point. So this is what I've got. My gradient is negative 1 over 16, and my point is 8.5. Okay, so this is the gradient of my tangent, and my point is 8.5. Now if I do, all right, we'll do this. So we're going to use our point gradient formula. So the equation of the tangent, I'll use point gradient formula, is y1 minus y1 equals mx minus x1. So we get y minus a half equals m, which is negative 1 on 16, x minus 8. Now, you'll be wanting to multiply. Remember, this is really negative 1 bracket x minus 8 all over 16. So we'll multiply the other side here by 16. And we're left with negative 1 here, x minus 8. So expanding this, we get 16y minus 16 times a half is minus 8 equals, and expanding this, we get negative x plus 8. So we go 16y minus 8 equals negative 1x plus 8. Writing it in general form, we need the x to be positive. We get x plus 16y minus 16 equals 0. So therefore this is the this is the equation of the tangent. Now if I was to sketch this, y equals 4 on x is a hyperbola, which looks like this. Okay, I mean I haven't got the exact values, but when x is 1, y is 4 up here. And the equation of the tangent to the curve at the point 8.5 would be somewhere down here, and it's a fairly, it's got a slight negative gradient. So if I took this half to the other side, see my gradient is negative 1 on 16, is negative 1 on 16, the gradient of this tangent, and we can see that okay? And if I was to work out my y-intercept, I think I get a half, I think I get 1. If I put this now in y equals mx plus b format, look, I get 16y is negative x plus 16, and so y equals negative x on 16 plus 16 on 16 is 1. So that's the equation of my tangent. It's got a y-intercept of 1, and its gradient is negative 1/16, so it's quite flat, okay? And just one more question, and that's question 14. So last question from exercise 8.7, it says the function fx equals 3 root x has f dashed x equal to 3/4, and you have to evaluate x. So we're given the function, and we need to find f dashed x, because we're just trying to find the value of x when the gradient function itself is equal to 3/4. Now we can't differentiate that at the moment. It needs to be written as 3 times x to the power of a half. Now we can differentiate it, and because this is x to the power of something, so we get 3 times, bring the half to the front, write down your x, and do a half minus 1 is negative a half. Now we want to simplify how this looks, so 3 times a half is 3/2, and x to the power of negative half can be written as x to the power of a half on the denominator. Writing this with without powers, like fractional powers, it's 3/2 root x. So that's what f dashed x is. Now, you have to find the value of x when f dashed x equals 3/4. So we're going to put sub f dashed x equals 3/4, and we get that 3/2 root x equals 3/4. Now, you can see how your numerators are identical. That means that the denominators are identical, that they have to be the same. Therefore, we can say that 2 root x equals 4 if we equate, so equating denominators, well, they have to be the same because the numerators are the same, so therefore the denominators have to be the same. That means that root x is 4 divided by 2. In other words, root x equals 2. But we're still not finished. Root x is 2. That means to find x, I would need to square both sides. So squaring both sides will give me x, therefore x is 4. Okay? The other thing we could have done, oh no, I would just do it like that probably. The following for homework, exercise 8.6, question 3D, 6B and C, questions 7, 8, 11, 13, 14 and 15. And from exercise 8.7, could you please do questions 3 to 6, 8 to 10 and 13 and 15. Thank you.